So on our guessing game, we had a nested loop. The outer loop asked them if they wanted to repeat the game. The inner loop actually made them guess over and over until they got it right. So in effect, this line here needed when values of two or more variables repeat to produce every combination of values. That doesn't quite cover what we did. Here's what they're saying. If you do something like this, x is equal to 1, while x is less than or equal to 10, y is equal to 1. I ought to make y'all type this in. Yeah, let's do this. Let's do this ourselves. This is going to be a nested loop that illustrates exactly what they're talking about. What am I doing there? File new. Do the usual. Save as April 10. Alright, so our outer loop, x is equal to 1, while x is less than or equal to 10. Y is equal to 1, while y is less than or equal to 10. Colon. Alright. So what we're going to do is let's print out, and I'm going to use a fancy syntax we haven't done before, I don't believe. And before we make it fancy, let's keep it simple. X comma y comma x times y. We're making kind of a little multiplication symbol. Multiplication. We're going to change a little bit more. X comma and then the words times or multiplied by or just the asterisk like that. And then after that y comma, I want another string that said equals or equal sign like that. So just pay careful attention to where the strings are and where the commas are. Okay, so inside the inner loop, which variable are we looping on? Y. So we need to do y is equal to y plus 1 or y plus equals 1. Then I'm putting an end while comment. I back tabbed it 1. And then underneath the end while, whoopsie, underneath it, in the same line, it's going to be, since the outer loop loops on x, we need to do x plus equals 1. And then one more end while. And people watching a video at home don't really need to watch the clock as well. There we go. Alrighty. So if I don't have any syntax errors, there we go. See what it's doing? 1 times 1 is equal to 1. 1 times 2 is equal to 2. 1 times 3 is equal to 3. All the way up to 1 times 9. 1 times 10. I'll bring the code back. Then 2 times 1 is 2. 4, 6, 8, 10, 12, all the way out to 2 times 10. And then 3 times 1, 3 times 2, 3 times 3, and so on, all the way out to 3 times 10 is equal to 30. So you can see that the first number is x, right? We printed out x. The second number is y. We printed out y. And then we printed out the product of the two. I don't think we need to make it any fancier. I was going to show you how to line it up in columns, but that's good enough. So there we go. The inner loop is looping all the way before the outer loop iterates. Again, iterates means repeats once. So the inner loop counts from 1 to 10 before the outer loop even increases 1. And then the inner loop counts from 1 to 10 again before the outer loop even increases by 1. So that's what they mean on their PowerPoint over here, where it says when 2 or more variables repeat to produce every combination of values. And that's what happened. You know, we have 100 different combinations here, 100 different possibilities, right? Because x can go from 1 to 10, Y can go from 1 to 10. And so 10 times 10 is 100 different possibilities. That's our nested loop. Anybody need a moment to finish typing that, or are we all good? All right. And of course, you can nest an if structure inside of a loop, or a loop inside of an if structure. We've talked about that already. You know, while x is less than 10, if, you know, x is equal to 5, do something, that kind of thing. All right, I'm in a hurry to get to the next topic. I'm hoping we don't have too much to go. This is all stuff that we've already talked about. Mistakes possible using the wrong comparison when testing the loop control variable. Programmers must use the correct comparison. Yeah, for example, if we have this and we made it just less than, rather than less than or equal to, it wouldn't count up to 10, it'd just count up to 9. So if we really wanted it to count up to 10, we'd have to make it equal to. Or alternately, you could make it less than 11, which would have the same effect. But our brains don't work like that, right? If we want to count from 1 to 10, we usually like to say less than or equal to 10. The seriousness depends on the actions. Overcharge insurance customer by a month. Yeah. Overbook a flight on an airplane. Yeah. Dispense extra medication. Okay. You know, those are pretty serious things. I don't know, if I got 5 extra pills, you know, I wouldn't mind that. But anyways. Mistake, including statements inside the loop that belong outside the loop. That's harder to do when you have these markers here, right? But I'm sure that a lot of y'all have had the pleasure of having me come over, and something doesn't work because it looks like this. Don't necessarily type this because this is just going to be a demonstration. If you wanted to type it in, I don't care. And then you had a return statement here that was supposed to return only after the while loop was completed. But if you left this tabbed over, what would it do? What would it do that's incorrect? Like that. Kind of looks right, but it's not. How many times is the while loop going to repeat before it returns? Just once, right? Rather than 10 times or however many times it was supposed to go. This one actually would go 11. There again, that mistake they talked about, making your condition correct. But anyways, it would only repeat once. Why? Because it's in line with the rest of the body. So it's going to print X, it's going to add 1 to it, and it's going to go, whoops, return. And it bails out of it. It only prints one thing. And several of y'all have seen that before, just because you didn't tab that over. You know, that's an easy mistake to make. Other programming languages, not all of them, but a lot of them use curly braces. That makes it kind of easier in a way to keep track of, because the indentation doesn't matter there. You know, if the indention's a little bit off, or you know, even if it's totally wrong, that's bad programming. You know, it's hard to read, but the logic, you know, as long as you can keep track of, oh, the return was supposed to go after the curly brace. Let me put a comment as to why this is wrong. Oh, come on. All right, I use that fancy word iteration again. That just means one repeat of a loop. This loop iterates 10 times because it's got the, you know, counts from 1 to 10. This loop is supposed to iterate 10 or 11 times. If I got my comparison correct, it would do it 10. But it only iterates once, only repeats once. All right, so like I said, don't have to type that in. That's notes. I always upload the notes, hopefully. All right, the for loop. Now it's kind of, all of their examples don't use our syntax, but I'm going to zoom in on it anyways. Or maybe I'll even type it. Here is the C++ and the Java syntax for loop. For x is equal to 1, x is less than or equal to 10, x plus plus. And then we could print out x. Now that's not our syntax, but that's kind of what the book will show us. But it was only this version of the book that added Python at all, so a lot of the examples aren't done in Python. But we can get the idea, right? You're going to start off x at 1, and you're going to count as long as x is less than or equal to 10, and every time you iterate, you're going to add 1 to it. So it would print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you just made this x less than 10, then it would keep repeating until x hit 10, so it would print out 1 through 9. That's kind of the Java C style. A lot of languages follow that. But the guy who invented Python liked to be completely different in some ways. So here's how you would do it in Python. A little bit different. Now I'm going to change this so that it looks more like the Python one. I'm going to change that to 11, and hopefully you all see why that counts from 1 to 10. Except in all these languages, the comments are double slashes. But anyways, this also counts from 1 to 10. Well, why did it go to 11? Because it stops when it hits 11. Just like this would stop when it hits 11. So it includes 10. This also includes 10. Now, personally, I wish that they'd gone ahead and made that, a less than or equal so that you could put the other upper boundary there. In math, junior high, high school, you did, inclusive and exclusive boundaries. 1 is inclusive, it starts at 1. 11 is exclusive, it stops before it hits that one, right? So that counts from 1 to 10. That's the Python syntax. We're going to print our same multiplication table out, except using for loops, just to make it a little bit easier to read. At least I think it's easier to read. Okay, I'm going to move this define out to the notes. I don't want it cluttering my code to make my code harder to read. All right. Alrighty. So for x in range, starting at 1, keep going until it hits 11, and increase by 1 every time. Then the same thing for y. For y in range, 1, 11, counting by 1s. If you wanted to count by 2s, right, you'd change that to 2. All right. I'm going to come up here and copy that print statement because it took a while for me to type it. So just go and copy it and put it in the right place. Save yourself a moment. All right, now we're done. Sure, I could put some comments in there, end for and end for. Now I'm going to delete the comments because in a way they are noise. What do I mean by that? They just kind of fill the eye out. They're useful, but okay, compare these. These two things do exactly the same thing. Which syntax do you like? Well, some people do like while loops. They like, understanding exactly what it's doing. Some people like for loops. I like for loops. If I can express my syntax like this, look how much shorter it is. That's the chief advantage of a for loop, is that it's much shorter. When I say it's much shorter, you are condensing 3 things into one statement. And what do I mean by that? Your standard while loop kind of looks like this. Let's go back down here. Your standard loop looks like this. X is equal to 1, while x is, I'm going to change it to 11. You understand it's still going to count to 10. You know, do something and then increment x, right? We have three things. We have a declaration, an initialization in one step. We have a comparison, and we have an update. Book may call it slightly different things. Seems like I've talked about this already. Maybe I'm thinking of the C class. Anyways, right? You have an init. You initialize that variable. You declare and initialize it. Then you have a condition. You test it. And then you update it. And in this case, you know, and that print x is just do something useful. In this case, all three of them are in this same place. We declare there, we test it there, make sure it's less than 11, and we update it there. That's why it's such a more concise notation. And you can see why the designers of programming languages invented that. Anybody need, whoopsie, did I go too fast? I'm typing the for loops. Wave your hand if I need to slow. All right. The reason I show adding end whiles and things like that is to make absolutely clear where the loops begin and end and why that one is back tabbed. But then I removed it so that, you know, it was kind of serving as visual noise just to compare the two. When you're doing production code, if you need to put the end whiles in there to make sure that you have everything lined up great, go ahead and do it, but you don't have to. All right, the step value is the amount by which the variable changes. This is a step of 1. This is a step of 1. What if we wanted a step by tens? Where's my code? Instead of going from 1 to 10, let's change it so that we're counting from 2 to 10 by 2s. So just copy that whole shebang there. Copy those three statements, paste them. Now we're going to start at 2, and we're going to keep going until it's no longer less than 11, but we want it to bump up by 2s each time. And the same for the while, the inner loop. Make it start at 2, keep going as long as it's less than 11, and each time increment it by 2. Step 2. All right, so the third time I run it, check it out. It's counting by 2s, right? 2 times 2, 2 times 4, 2 times 6, 2 times 8, 2 times 10, 4 times 2. So why did it do that? Because we told it to increase by 2 each time rather than 1. What if you wanted to count it down rather than 1? We're going to do a countdown. It's the final countdown. All right, so for x in range, we're going to start at 10. We want it to stop when it's no longer greater than 0 or when it hits 0, and our step is going to be -1. And let's print out x. So if I did this right, it's going to count from 10 to 1. All right, and it did. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You see how that works? We started it with the upper value rather than a lower. We set this equal to 1 past the lower. We want it to get down to 1, so we set it to 0. And then each time we want it to subtract 1. For loops are pretest loops, just like while loops. What is a post-test loop? A post-test loop is one that checks after it. And Python doesn't even have one, so I'm going to show you what it looks like in other languages. Don't type this into your Python code. This would be what it looked like if Python did support a post-test loop. Something like that, except they probably put a colon here, you know, and remove the braces. But anyways, it's called post-test because the test happens after the body, after the do something useful step. Whereas a pre-test, you know, has the while up at the top. Is there an advantage to it? Well, if you want the loop to always execute at least once, in a language that supports a post-test loop, you'd want to do it this way, right? Because it will always do the print X. What do I mean by that? There's no test here preventing it from getting to that statement. You know, even if we set X equal to 100, it's still going to print out 100 before it, oh, by the way, this is an infinite loop because I forgot to, you know, modify X. But anyways, it's going to print out X even though X is less than 10. It's not going to figure out that X is less than 10 until the end. Let me go ahead and, for completeness, add my X plus equals 1 there. But if you used a pretest loop, X is equal to 100 while X is less than or equal to 10, print X, X plus equals 1. How many times is it going to print X? Once? 0? Yes. Once is a good guess. It's not correct. Why do I say it's not correct? This is like an if statement. Is X less than or equal to 10? Somebody say no. No. So it can't even get in here, right? Just like if it said if X is less than or equal to 10, it can't even get in here. So this code would not repeat at all. This code would repeat once. So if you had some code that you always wanted to execute the loop at least one time, no matter what the starting value is, you'd use a post test. But we wouldn't because we're programming in Python. And there's always a way to do things even though we don't have a post test loop. I'm not going to show you how. When you get to Java or C++, you'll learn your post test loops. I almost never use them. So here's our flow charts for a post-test loop. This is a while loop. While something, do something. This is a post-test loop. Do something while condition, right? So it always does the process before it does the decision. All right, common loop applications, and I'm pretty sure we've done this before. We've used like summation loops that add up from 1 to 10, right? You can do the same thing to accumulate total, right? You could ask for a list of, you know, scores, and you could add them all up, and we've done that as well, right? It's kind of a test program that you input scores, say yes or no. I'm not seeing a lot of heads nodding. I mean, have we done it? We're going to do it again. Not, a lot of people were not looking sure. Okay, so here's what we're going to do. We're going to write a program. Let's pretend that in bowling you can only score, you know, 5 times. So we're going to set a limit. For X in range, starting from 1, going up to 6 because we want 5 times, counting by ones. But we need an accumulator, something called total. You could use sum, but sum is a function name that's built in, and if you use it, then you're kind of erasing the sum function that you might write. So total is equal to 0, right? Because your total can't add anything until you have a variable. So you have to declare it. All right, so we're going to get our input. Score is equal to input I should have put a print statement in front of it because I actually want to print out the round. So print score for a round number. You know, I don't play bowling. I don't know what you call them. Are they called rounds or turns or what? Frames. Okay. Score for frame, end quote, comma, X. And then we just input like that. And guess what we always have to do when we're trying to input a number? We have to convert it. How do we do that? Yeah, score is equal to float score, and let's add it to our total. Total plus equals score, or if you like, total equals total plus score. After our loop is done, let's print out our total. Like that. Because how many times in the real world do you just want to add up all the numbers between 1 and 100? You don't. But you like adding up numbers, you're just not adding up sequential numbers, right? You're going to open a file, you're going to add up all the paychecks, calculate, or add up all the costs, the number of orders times the price per item, that kind of stuff. Add up all the debits and the credits in your checkbook, whatever. So here we go. I'm going to run it. Hope I don't have any syntax errors because it's going to take a while. Alrighty, so it says enter score for frame 1. I got 5. Then I got a 7. Then I got a 4. Then a 0 and a 0. And it said total 16. I guess that's right. 5 plus 7 is 12 plus 4 is 16. Okay. So this is accumulating. What's the exact word they used here? Accumulate. Okay. I'm going to put a comment up here. This is called accumulating. This is the accumulator variable. And then that's the loop that gets the data and adds it to the accumulator, right? I'm not going to add any more comments. I hope that that makes sense. What would happen if I put that print tabbed over like that? Thought problem.
Only print it once, or only after one round?
You're almost at the right answer. It's going to print it after every round,
Oh.
right? There's nothing causing it to exit after just one loop. But it's not going to wait until after the loop is done in order to print it out. Instead, it's going to add the total and it's going to print it out. It's going to add the total and print it out. Maybe you like seeing a running total. That's what you want. If you want to see the score each and every time rather than wait until the end, that's pretty cool. You might want it that way. One thing I see people do is calculate the average every single time. Right? They'll have some line here that calculates the average. You don't need to calculate the average every single time unless you're trying to print it out as you go. Right? You would want to calculate the average after you got your total because the average is equal to the total divided by the number of items. You don't need to calculate the average every time. But I don't count people wrong for putting that in there. It's just wasted time from the computer's point of view. All right, I want to veer to something that the textbook is not talking about yet, which is using lists, which other languages sometimes call arrays. And I think we may have used this once or twice, but I want to do it again. What if we had a list of scores already? We opened up a file and we read them or something like that. They were already defined in a list. 10, 9, 1, 5, 0, right? So its scores is equal, and that's a square brace, not a parentheses for you guys in the back. Now we can add them up in a different way. For score, you know what, I'm just going to do for x in scores. Here's how I would like to do it. Don't type this. For score in scores, this is perfectly good syntax for every score in the score list. It's good syntax, but invariably people start leaving out the S's or putting them in there, and when I say people, I include myself in that. So I'm just going to make a different variable name. For x in score, total plus equals x. Now I've made a mistake here. And then print the total out again. Print total, comma, total. All right. Can you eyeball what I did wrong? No big deal if you don't, but I didn't wipe the total out before I went in there. So it's just going to start adding things onto our previous total. So I need to reset our accumulator. So above our for loop, total is equal to 0. And the other thing that, and you're right about that, another thing that might be nice is if we printed out the score that we were adding, right? Because otherwise nobody knows why all of a sudden we have a different total than we did up above. So let's add a print statement. Print adding, comma, x, comma, to total. And then when it runs, we're going to see that it says adding 10, adding 9, adding 1, adding 5, and adding 0. Hopefully. It's going to get real annoying having to answer these questions every time. And it blew up. Alrighty, I did something wrong. Ah, there I go. I didn't put an S there, right? Told you I'd mess it up. Since that's scores, and I want to iterate through that list, I have to put an S there. Now maybe you got it right and I didn't. But if you get a syntax error there at the end, that's probably what it is. Just make sure it says for X and scores with an S. All right. And so it added 10, 9, 1, 5, and 0 and got 25, which I trust is right. Yeah, it is. All right, about time for me to walk about. Make sure we're all good together. All right. All righty. Defensive programming. Preparing for all possible errors before they occur. What does that mean? Well, if you're entering test scores, you might make sure that the scores cannot be less than 0, right? You could have a if statement or even a while statement that asked over and over and over until they typed in good data. So that's validating data. If they type in a month, make sure that the month is between 1 and 12. If they type in a year, make sure it's 4 digits long or 2 digits, you know, if they like typing in slash, you know, 02 or whatever. Then there's a phrase, garbage in, garbage out. If somebody enters bad data, then the output is going to be wrong or even crash the program. Alrighty, limiting a reprompting loop. Reprompting can be frustrating to a user if it continues indefinitely. Maintain a count of the number of reprompts. And then what? Tell them that they're lame and exit the program at that point? I don't quite get what they're telling me here. But yeah, you could make it so that, you know, it keeps asking, enter a score or -1 to quit. And if they keep getting the score wrong, they can always just give up and type in -1 and bail out of it. One thing you can do is override incorrect data by setting the variable to a specific value. Like if you're going to ask them how old they are in order for some calculation and they type in a number less than 0, then you could say assuming age of 10 or assuming age of 20 and just run with it. Now that's usually not a good idea, but it may be better than breaking the program, you know. Just tell them that you're doing that so that when they go and look at the results, they see why it used an age of 20 or 10 or whatever. So there are different ways of validating data. Is numeric. There's a version of that for Python, which checks to see if what they typed in is really a number. Because I think we've seen what happens if you type in a, you know, a score and it's not really a number. Let's do that. You don't have to run it, but I'm going to illustrate it. So I run it, it asks me for a score, and I type in 2.8, whatever. Well, I don't, yeah, okay. So I typed in 2.a and it said could not convert string to a float. Why? Because .a is not valid, valid numbers. So the right thing to do would be to make it able to handle that. Tell the user, no, that was invalid data. Now, unfortunately, the function that checks for valid data, valid numeric data, does not include decimal points. So you cannot really check for floating point valid data. But you could check for whole numbers, and we have been really using whole numbers here. We didn't let them enter a negative, a fractional score. You scored a 3.3 on this frame, So I don't want to make this too complicated. Too late. We're going to write something that validates the data. If the data is not valid, we're going to skip the conversion, and we're going to skip adding it to the score. So I'm going to modify this for x equals 1, 6, 1. So as soon as I read this in, I'm going to check to make sure that it's numeric. And honestly, I forget. I think it's isDigit. Yeah, okay. So here, before we turn it into a float, because that's the line that blows up if they type in invalid data, right? If they type in a word rather than a number. So what we're going to do is we're going to say if score.isDigit, colon, and then we're going to tab these two things over. We're tabbing those two lines over. Score is equal to float score, and total plus equals score. So here's the line that I just added. You don't have to type that comment. I'm just showing you. That's the line that I just added, and I tab these two guys over. So what's that going to do? If they type in something that's not a valid integer, it's going to blow up. Now, we're not telling them to type in a valid integer, so maybe they think they can get away with typing in, 3.1 rather than just 3, But this is just an example. It's not a really thorough example, but it handles ints, whole numbers. All right, enter score for 1. Now, if I type in A, ew, it blew up. Could not convert string to. I thought I'd already handled that. Well, if this doesn't work, I'm going to delete my changes, but I really wanted it to work. Is that line 30? Oh, I forgot this is a function call, so I need to put parentheses after it. Newbie error. Okay, there we go. So it needs to be score.isDigit, like that. Make sure you get those parentheses there or it's not going to work. Alrighty, so if I type in garbage, it just ignores it. We ought to tell the user that, right? We ought to say, bad data, assuming 0, something like that. But at least it's not crashing, whereas it would have crashed before. Now, like I said, the problem with this Python function is that it doesn't support decimal points. You would have to enter digits only. We could write our own function that would make sure that it accepted a decimal point as well as isDigits. I would like to go ahead and add that one little more bit of code that prints out the error message. So underneath that total plus equals score, I'm going to back tab and do else colon print bad input parentheses assuming 0. Now make sure that you back tab the else so that it's lined up with if, and then that this is tabbed over 1. And then it's time for me to walk about again. All right, so for can I talk? Oh, come on. Score for frame 1, 10. Score for frame 2, A. Bad input, assuming 0. Score for frame 3, 5, 7, 10, whatever. And so it added all of them up and it gave me the total, 32. Okay, I do want to make sure that everybody got this. This is an example of nested code where we have an if statement nested inside of a loop. We could write this to be a while rather than an if. Why would we do that? We might want to insist that they enter good data, right? And each time they typed in bad data, we wouldn't let them escape the while loop. But I think this is enough for now. This is an example of using a function that's part of the string class. Because strings are a class, we haven't talked about class, but it's a data type. But the string data type has a whole bunch of functions. You could check to see that it's all uppercase, or that it's all lowercase, or that it's all letters, or that it's all numbers, or that it's all special symbols, you know, that kind of thing. You know, by special symbols, I mean punctuation and stuff like that. So this is a way, you know, isDigit is one of those. Just tuck away in your brain that the string data type has functions embedded within it that you could use to check to see what kind of data it is. All right, I want to go back to the idea of lists. Like I said, even though it's not in this chapter, it's incredibly important stuff. So I think I'm tired of seeing all that, you know, those numbers print out and stuff like that. So I'm just going to stick this up at the top of the code. I'm going to go to the very top of the code. And so I want to define a list. Names. And I want to put 3 names in there. Each name has to be separated with quotes. So Joe, pick whatever names you want. End quote, comma, beginning quote. Bob, end quote, comma, beginning quote. Mary, end quote, end square. Now again, since this is a list, you use square braces. That's how it knows. If you put parentheses, it's not going to be a syntax error, but it's also not a list. Something called a tuple, which we're not going to really talk about. Alrighty. Now if we wanted to print out that first name, here's how you get out each element. Now computers start counting at 0 when you're talking about arrays or lists. It's called zero-based indexing. So if I want that first value, I'm going to have to do this. Let's say A is equal to names subscript 0. And when I say subscript 0, I mean in square braces. I don't know who came up with that term subscript. B is equal to names subscript 1. C is equal to names subscript 2. And we could print them out. Print A, comma, B, comma, C. Or heck, let's print out C, comma, B, comma, A, just so that we see them reversed. But so that it won't do all the rest of that stuff, I'm going to put an input statement underneath that that says press enter to continue. And then I can just close the window, right? That way I don't have to let it go all the way down to the, you know, keep running. So it printed out Mary, Bob, and Joe. It printed them out in the opposite order. So here's what's important about that. One is that you start counting at 0. That means that since the length of the list is 3, you can only count up to 2, right? Because this is really 3 things. 0, 1, 2. You know, humans start counting at 1, 1, 2, 3, 4, 5. But computers start counting at 0 when you're talking about arrays or lists. 0, 1, 2, 3, 4. So since I have 5 fingers, I counted up to 4. 0, 1, 2, 3, 4. I had 3 items here, so I counted 0 to 2. Now what if I want to change one of those values? I can do that. What if Bob quit the job And we're going to replace Bob with somebody else. So B subscript 1, because that's element 1, right? This is element 0. So we're going to change element 1. Who are we replacing him with? Tim. And now let's just print out the whole list like that. So when I print it out, instead of printing Joe, Bob, Mary, which it would if I hadn't done this change, it's going to print Joe, Tim, and Mary. Because this line of code changes element 1. Joe is 0, Bob is 1. It's going to change Bob, element 1, to Tim. And string object does not support item assignment. I've made a mistake. What'd I do? Oh, for Pete's sake, you're right, you're right. Here's my mistake. I said B1, but what's the list called? It's called names. So I should have done names subscript 1. Thank you. I might have stared at that for quite a while. All right. So it did, in fact, print out Joe, Tim, and Mary, which is our new list after we've changed element number 1, the second element. Kind of messes with people that element 1 is the second element, element 2 is the third. That's why I keep hammering that over and over and over. What happens if you access an element past the end of the list? What if I printed out names subscript 3? Well, if we count out our elements, this is 0, that's 1, that's 2. There is no element 3, so it would crash. You can check the length of the list. There's a function that returns the length of the list so that you make sure that you're not, going past the end of the list. Now here's a little quirk that Python does that other languages don't, which is that if you use -1, it goes to the end of the list. If you use -2 as your index value, it goes back one more, and if you use -3, it goes back one more still. So just for giggles, I'm going to print out names element -1. And that would crash any other language I've used. But Python's happy to do it. So it's going to print out Mary. In fact, I better put a comment here. -1 is the last element of the list. Now, why are we doing lists before we get to the chapter? Because that's how we roll. I like for y'all to have seen it in code before we hit the book on it. Because then you already have a feel for how it works, and then the book is reinforcement for that. Because otherwise, my tendency is to spend too much time lecturing on that particular point before we ever use the code. This way I know how much we need to lecture on it. All right. So I printed out Mary because -1 was equal to the last element of the list. -2 would have been Tim. -3 would have been Joe. Hope that makes sense. Syntax errors? Now, when I say syntax errors, I also mean logic errors. Like if your code is in an infinite loop, that's still a problem I need to come and help you with rather than wait for 30 minutes. So anyways, let's look at the PowerPoint again. So these are the name of some methods in other languages. Is it uppercase? Python calls it isUpper. Is it white space? I think that's the name of the Python method. Is_char? That would just be isAlpha in our language. We would ask them if it's a character. Or not ask them. Validating reasonableness and the consistency of the data. Good defensive programs try to foresee all possible inconsistencies. Like if you're reading a list of data, a list of values, and suddenly it seems like something is off. And what do I mean by that? All of the scores you've been reading have been between 1 and 100, and then all of a sudden you get a number of 9,982. Then that value, there's something strange about it. You know, like what if you had a sensor that was reading temperatures, like to control a thermostat or whatever. And so each day you recorded the temperature, but then when you wrote a program to read it, you would want to check to make sure that it was a reasonable temperature, because something like that's probably an equipment failure. That's called defensive programming, accounting for bad data. Because what programmers always do is they write the program to work. What do I mean by that? As soon as it works, woohoo, I pump my fist and I go on to my next problem. But also, you should try to you should also test your program to see if you can get it to fail. And if you can get it to fail, then you fix that. Now, we haven't learned all the ways that you can fix that stuff, but that's the idea. You don't want the end user to be able to crash your program, or you don't want bad data to be able to crash your program. All right, so loops write one set of instructions that operate on multiple sets of data. What do we mean by that? Whoopsie. Down here, when we were adding up sums, we just wrote one set of instructions rather than repeating this code 5 times or 10 times or however many scores we have. We just looped it. We didn't want to copy and paste that code 5 times or 10 times in order to handle every piece of data. We just put it in a loop. 3 steps. You have to initialize, declare and initialize the loop control variable. X is equal to 0, Y is equal to 1, whatever. You have to compare, and you have to alter the variable that controls the loops. Now, there's about one more topic in loops that this text doesn't cover, but we're going to talk about it. It's pretty important. Nested loops are loops within loops. Nested loops maintain 2 individual loop control variables, like when we did X times Y. X and Y were our loop control variables. And then when we did our guessing game, we had a loop control variable called guess, but we also had one called repeat. And it kept repeating as long as repeat was equal to Y. So that was indeed a loop control variable, even though it wasn't a counter. Common mistakes: neglecting to initialize the loop control variable. If I do, while X is less than 10, but I never set X equal to a value, that's an error. And I made a mistake later on where I forgot to reinitialize total. Or I almost made that mistake. And if I hadn't reinitialized total, it would have added all the new numbers back onto the old ones. Neglecting to alter the loop control variable. If I didn't have X plus equals 1 or something like that, then it would be an infinite loop, because the loop condition would always be true. Using the wrong comparison. Including statements inside the loop that belong outside the loop, like when I had my return statement, but it was in the body of the loop, so it only iterated once. Most computer languages support a for loop. We've talked about that. If you know when the number of iterations is known, right, you know the range of data, use a for loop. Or if you have a list of data, use a for loop. If you don't know how many iterations there are, you're going to use a while loop, right? Like if you're asking the user to enter a series of data, but you're going to want to let them enter -1 to stop, you don't know how many they're going to enter before it needs to stop. Or if you're reading from a file, you may not know how long that file is going to go. So you probably wouldn't use a for loop in order to read a file. You would use a while loop. You'd keep repeating as long as you had data in the file. And then that good old post-test loop. If there's a question about post-tests on your on your MindTap quiz, great, go ahead and answer it. I'm not going to ask it on an exam in class. You can use loops to accumulate totals. You can reprompt users for valid data. We didn't show that, but here in our code, when I checked to make sure that we had good data here, when I did if score.isDigit, I could have made that a while statement, and we could have kept reprompting them. Print bad data, try again, that kind of thing. In the loop structure, the paths that emerge from the test do not join together. That's kind of abstract. But we showed it last time. If I go into a lucid chart, you know what I meant to do is to make us do a flow chart for the guessing game. I might still do that. Do I have a nested loop? Yeah, here's a nested loop. Come on. Write our outer loop while x is less than equal to 10. Our inner loop while y is less than or equal to 10. That's how you flowchart it, or some variation of that. Right? Because a while loop always has the line going back up to it. And so this one would repeat that body of that while loop. And when it was finally done, it would go and repeat the body of the outer loop. Now, is there more than one way to draw it? Yeah. You know, if you want to, you could kind of draw it like this, where it went back like that. And then if you wanted to, you could kind of make this one go like that, all the way over there. And then it kind of looks lousy, in my opinion. I'm not even sure how the textbook shows it. We could do that. Something like that. I think that's lousy looking. But whatever. As long as you have one line going back to the end of the while, and then another line going back to the end of the outer loop while, then you're golden. Other comments I need to make after grading flowcharts is you can't have multiple lines going to the same thing. You know, if I had a block here, oh, come on. All right. That's wrong because we have two things going to a block. The only time you can have more than one thing going to a block is if it's just a connector like that, or if it's a while loop like this, where you have, you know, a line coming in and then you have your loop line also coming back in. So if you're looking at your flow chart and you have multiple lines coming into the same block, that's not good. Now, yeah, some people would leave out the connector and, you know, put something down here and understand that. But let's not do that. Let's always use connectors. Okay, the last thing I want to talk about loops before we're done. Is there such a thing as a break? A break lets you exit a loop early. That's what it means. And I think I've used it before in here. But something like this. While x is less than 10, do something, and then if error, break. Now this is not going to compile. This is kind of more like pseudocode. And then otherwise update x. What break means is leave the loop early. Jump down to whatever's down here. Don't keep repeating the loop. It exits the loop instantly. It wouldn't even run this code. So sometimes I will write a loop like this. And the books don't show this, and I think I've mentioned this. While true, you know, x is equal to input, you know, enter name or Q to quit. And hopefully nobody's name is Q, but I guess we're not Star Trek fans. And then if x is equal to Q, then break. Else, do something with that name, right? Print hello, comma, x, like that. What does while true mean? It means repeat infinitely, right? Because this condition is always true. But since it's going to repeat infinitely, we need some way of leaving a loop. One way is to put a break statement in there. Under certain conditions, whatever you define your condition to be, once that condition is hit, leave the loop and come down here and start running stuff. And usually I introduce the concept very early in these programming classes, but since the textbooks have, this textbook hasn't been talking about it, I've been leaving it out. Just tuck that away in your brain. I don't think I'm going to be asking any questions on the exam about break statements. But you'll see them in almost any language that supports looping. You can break out of a for loop. You can break out of a while loop. If you're using a language that has a post-test loop, a do loop, you can break out of a do loop. You could also put a return there if we were inside a function, if it looked like this. Define function, right, and then the same stuff. X, while true. While true just means keep repeating infinitely. X is equal to input if X is equal to Q, then return. Otherwise, print hello X. That's a function, so this would kind of serve the same thing as a break, right? It would bail out of the code as soon as we hit that. That would be the same thing as writing this. And this is probably, arguably better, I won't say better, by the book programming. Instead of doing a return right there, we do a break, and then after the loop is done, we do a return. The problem with the break statement is that no textbook shows how to flowchart it. So I make up a way to flowchart it, but I don't feel like showing it to y'all. So we're just tucking your brain what a break statement does for the next programming class you take. And I hope you all come and take my Java class or my C++ class, because y'all are all doing pretty good, pretty dang good. It's kind of strange. Sometimes I have a class, right now I'm teaching 2 fundamentals. Sometimes I have a class that works where one of them is acing the class far more than the other one. And when I say acing the class, this class is turning in a lot more of their homework than the other class. And the last 2 semesters that has happened, it's because the larger class, which is held in the other room, had a lot more people. And I don't know if it because there's a lot more people in it, if people space out, you know. I haven't figured it out why the classroom size would inhibit people from turning in homework. It doesn't make sense to me. But 2 semesters in a row, the smaller class has been the one to ace it. So y'all are in the smaller class. Y'all are doing good. But if you haven't turned some homework in, please turn it in. And remember, if you get a really bad grade on an assignment, or if I tell you to redo it, redo it. All right, let's make a Dropbox for what we've done. We're at the end of the chapter. I don't think we need to spend 2 minutes on getting into the next chapter. But we probably do need some homework over it. Let's crank up some homework for it. Yeah, we don't need any homework. All right. Write a while or for loop that counts from 1 to 100. Write a while or for loop that counts from 99 to 1. So you can have a minus equals or something like that. And then write a while or for loop that counts from 10 to 100 by tens. So it's just going to be 3 while loops. And our notes today, the code we've written today, show you how to do that. Alrighty, let's make a Dropbox.